In this video, I'm going to be talking about work and power. Before we get started with some specifics and examples, let's define what work and power are. As you can see, these definitions are simply put, work is the amount of energy transferred, which can be positive or negative depending on if the object or person is gaining or losing energy from something else, and power is the rate that energy is transferred. So it's basically measuring how quickly work is done. Work is going to be measured in joules because it's talking about a measurement of energy. And then because power is a rate, it's measuring the amount of joules transferred per second, which is more commonly known as capital W for watts. So let's take a look at our examples over here to the left. Work is the product of force times distance. So depending on the amount of force applied and the distance in which that force is applied, it's going to cause a certain amount of energy to be transferred. Now, because of the conservation of energy, that means that something else has to lose energy in order for something to gain energy, and vice versa. So this person is using their chemical energy to pass their energy onto the hockey stick, which then passes it onto the hockey puck so that it can gain kinetic energy. In some cases, if you're looking at some more of the specifics, work can also be the force times distance times the cosine of the angle at which that force is being applied. So it looks like a force is being applied at an angle here. So you would take the cosine of that particular angle and then multiply that by force times distance, and that would give you the amount of work transferred. In both of these cases, that would be considered positive work because the work is being transferred into the actual object, making it increase its amount of energy. In these two cases, it's the amount of kinetic energy. Now, there are cases where objects or people have negative work done on them. So say, for example, a person is the system that you're focusing on. Typically, if they're falling, they have an increase in kinetic energy because their gravitational potential energy is decreasing, and overall the person's total amount of energy remains constant. Now, if they have a bungee cord attached to their feet, then it won't allow the kinetic energy to increase the way that it normally does. It'll actually make the kinetic energy eventually decrease and reach 0 joules of energy once the bungee cord gets stretched all the way to its maximum point, and then allow this bungee cord to increase its elastic potential energy. In that case, you would call that negative work because the bungee cord itself is pulling out energy from the person, causing them to lose kinetic energy, and then in turn causing the bungee cord to gain elastic potential energy. So depending on what you're focusing on for your system, it could be a positive work, energy being pumped into the object, or it could be negative work, energy being removed from the person or the object. Now, focusing on power. Now, power is taking a look at the rate that energy is transferred. So it's basically talking about how quickly these things are being done. So these three examples here are just talking about a certain amount of energy, Now for power, now you're really focusing on how quickly that energy is being added or subtracted from the system. So say for example, you have two people who are lifting up identical barbells the same height off the ground. If they do a certain amount of work, they're going to allow the barbell to gain a certain amount of potential energy. So we'll say that is 1,000 joules each. Now, these people have done the same task, lifting the same barbell, the same height off the ground. So each of the barbells now has 1,000 joules of energy transferred to it. Now, if you were measuring the power output, now you're focusing on the time. So say, for example, the time for person A is 1 second, and the time for person B is half a second. Now, because person B was able to complete that task more quickly, their power output is greater. Because when you take their work and divide it by that smaller number of 0.5, because this is exactly half the time of person A, that's going to give them double the power output. So when you're taking a look at power, you're not talking about the amount of energy or the task that's being done. It's just the rate at which that energy is transferred. I hope those examples were helpful in helping you understand work and power. Thank you for watching and listening.